Welcome to today's webinar on functional safety management, specifically for managers. It's very interesting. I've had many conversations with managers, and it seems that a lot of them have responsibility from a budget perspective, but they don't really have a full understanding of what the implications are for them and for any cuts they make in any spending on functional safety. And interestingly enough, when I hold the FSC 100 classes and ask the question that who's responsible for safety, I get usually quite a few hands go up. And then when I say to them, how many of you are responsible for your budget? Of course, all the hands go down again. So hopefully this will be interesting for managers. Just a little bit about Exida for those of you that don't. I know that many of you attend our webinars, so please just indulge me a little bit longer. We are a customer-focused company. We've been around for nearly 20 years. We do operate in most industries, both from a functional safety perspective and from cybersecurity perspective, and also from an alarm management perspective. So we work in automotive, we work in industrial, we've even worked in nuclear as well, and machine industries. So we have developed a comprehensive set of life cycle tools to support the safety life cycles, along with the certification and assessment services we provide for both products and for personnel. And more recently, we've been doing a lot more cybersecurity certification for products. Coupled with that is all the life cycle services that we can provide throughout the safety life cycle. We are a global company. We have recently added our India office in Mumbai, but we've been around, as I said, for nearly 20 years and have a pretty good presence around most countries in the world. So how do we measure our success? Well, we've got the leading market share globally for safety device certification. And also, we've done more cybersecurity certifications than anybody else right now. We're not just owned by two people. The original company was started primarily by two people. It's now nearly completely employee owned, and that's intentional because obviously people think that if the two founders retire, then that's the end of Exida. No, it's not. And they're actually engineering that very process to make sure that Exida continues and is remaining in a very strong position. We've got more than 100 global experts worldwide. We've got over 500 years of combined knowledge and experience. And we've also done 1,000 certification and assessment projects and modeled over 500,000 SIFs. So it's a pretty reasonable statistic. Oops. Reference materials. We do publish a lot of books. There is a lot of information available through the website. All these webinars are recorded and you can find them as YouTube videos on the website. So under the archive, if you look under our resources tab, you'll see white papers and blogs and also webinars. In fact, there is a paper that supports this particular webinar I'm doing today, which I shall be presenting at a conference next week. A little bit about me. Some of you know me already. I've been in industry over 41 years now, mostly in the functional safety world, but also in the DCS world. And I'm responsible for our end user services business. Plus, I also teach a lot of the functional safety engineering FSC 100 courses. I've written quite a few papers and publications, and you can always find my webinars on the website as well. Okay, so much for the introduction. Let's get to the meat. So functional safety management, FSM for managers. So first thing that managers need to know, especially if they're working for an organization that comes under, in the UK, COMA, or comes under OSHA in the US. So basically, this requires these operators of hazardous processes to follow best practice. So what is best practice? Well, often called RAGAGAP in the past, recognized and generally accepted good engineering practice. This really relates to IEC 61511 for the process industries, whereby this is recognized as being best practice. 1511 is built around a safety life cycle, and the safety life cycle has three primary phases. There's the analysis phase, where we do our risk assessment and risk analysis, understand what our hazards are and the consequences of those hazards, and look at what mitigation or layers of protection we can put in place to help reduce those risks. Then we go into the design and implementation. This is where, if we determine we need to have a safety instrumented system with safety instrumented functions with target SIL levels, then we have to design it and create an SRS initially and follow that safety requirement specification, make sure we implement the system correctly. And then we have the operation and maintenance phase, where we install, commission, and basically start our operations. And this is where the old adage of 20-20-20 comes in. 20 weeks in design, 20 months in implementation, and 20 years in operation. That's typically what the old footprint used to be. So of course we're going to be spending most of our time in the operations and maintenance, and that's where a lot of the requirement for doing the functional safety management comes in. If we do it right, actually, we will end up with a design that's balanced against the risk requirement, risk reduction that we need to do, plus also we get an optimum cost. And if the performance is good, if we maintain the system correctly, we won't get as many false trips. And of course, every time we have a false trip, that can be extremely expensive, plus also extremely hazardous, because you have to start back up again. So the life cycle, as I explained, the three phases, and what governs the life cycle, if you like, the glue that holds it all together, is functional safety management. And functional safety management requires us to have proper procedures in place, and there are five functional safety assessments that we need to do throughout the life cycle. And you'll notice here on the right, we've indicated ones in blue and the ones in red. And I'm going to talk about that a little later on in the webinar and what that means and why the difference. So the objectives of the safety life cycle is that we want to avoid some of the problems of the past, where we may end up with expensive over designs, or worse still, expensive under designs that don't achieve the amount of risk reduction we're trying to get to. And the purpose is to help us avoid systematic faults and reduce the potential for random faults. And functional safety management is specifically targeting the systematic side of things that we'll talk about in a minute. So why do we focus on systematic? Well, because studies were done. The HSC, the Health and Safety Executive in the UK, did a study in 1995, and then they redid it in 2003, where they looked at the causes of accidents involving control systems. And what they found was there wasn't a huge difference between what they did in 95 and 2003. And what they were finding is that 44% were attributable to specification issues, whether it was a bad specification, whether it was incorrectly specified, wasn't covering everything, but 44% were due to specification. A further 15% was due to design and implementation. Well, of course, if the specification's not going to be right, then you can hardly expect the design and the implementation to be right as well. A further 6% were installation and commissioning, but on the O&M side, you can see there's 15% due to maintenance, but 20% for changes after commissioning. So this is another area where we have to focus particularly, and where functional safety management is very important. And this has been recognized by the IEC, and the 2016 standard puts a lot more emphasis now on functional safety management. So we know that we have to manage risk, and the ALARP model is very familiar to a lot of people. And what does ALARP mean? Well, it's as low as reasonably practicable, and that's a lovely English term, because this was developed or devised by the health and safety executives. So what this shows is that we should be trying to ensure that our risk is within the ALARP tolerable region, which is between 10⁻³ per year for workers. In other words, 1 death per 1,000 years per worker, down to 1 death per 1,000,000 years per worker. And for the public, it's 10,000 years to 1 million. So, of course, most companies try to get into the 10⁻⁵, 10⁻⁴ range. But this is how we define whether we're in our acceptable region. And of course, it really depends upon the company and its culture and its stance towards taking risk or not. And dear old Trevor Kletz, who's no longer with us, who was the old ICI guru, and also he was at Texas A&M, he used to say, if you think safety is expensive, then try an accident. And here you can see, this is a table taken from our Practical SIL Target Selection book, which looks at the accidents that have happened since the 80s. And if we go back to 89, some of you will probably remember it, some of you won't, because you weren't around. The Exxon Valdez oil spill in 1989. There was nobody injured, nobody killed, but the overall estimate was about $8.5 billion back then for the cleanup. So nobody killed, nobody injured, but still $8.5 billion. The Olympic pipeline explosion in 99, there were 3 fatalities and 8 injuries. The overall estimate was greater than 160 million. Property damage was around 45, but 75 million was paid to the families of 2 boys who were killed. They were playing near the pipeline when it went up. As a consequence, 2 former Olympic employees pleaded guilty to felony pipeline safety charges, and they received jail terms. Then there was 36 million in civil and criminal penalties as part of a deal with the federal prosecutors. So again, if you think safety is expensive, try an accident. The Texas City explosion, 15 people died, 180 were injured. It cost BP more than $1.5 billion, with a 50 million settlement with OSHA for safety violations. And the sad part about that is that they didn't learn from that, and 5 years later we had Deepwater Horizon. So it just shows you that safety culture is extremely important. Capico refinery, there was 8.2 million for cleanup costs. Nobody hurt, nobody injured, nobody killed, and of course it was enough to cause them to go into bankruptcy. BP's estimate currently, and I googled this the other day just for my own curiosity, their estimate is now nearly 62 billion is what it's costing. I mean, that's unbelievable amount of money. The San Bruno pipeline, 8 were killed, many injured, and the PG&E company agreed to pay 70 million to aid the city of San Bruno. And the Trans-Alaska pipeline spill was nobody killed, nobody injured, but 45 million in lost production and 13 million lost in state revenue. So again, if you think safety is expensive, try an accident. I can't tell you the number of times I've spoken to management teams, executive committees, where they say, well, we've never had a problem, why should we worry about it? And of course, the answer to that is, well, you've probably been lucky. And if you do have an accident, be prepared for OSHA to come in and really get to work on it. So in this case, jail terms were meted out. This is the other thing that can happen. If as a manager, you are responsible for cutting costs, and as a result of that cost cutting leads to problems with maintaining safety, and there's an incident and people are killed, you could end up going to jail. And all of this reflects a poor safety culture. So commitment to safety, the culture has to come from the management team. It has to come from the top all the way down. It's no good the people who are trying to implement functional safety, if they're trying to do this and management is continuously pushing back saying, Why do I have to spend money to replace that equipment when it hasn't failed just because the manufacturer says I need to replace it? These are the sorts of arguments and conversations that typically occur. So the purpose of the functional safety management is to, as I've said, govern the whole life cycle, not just the analysis phase or the design, but the whole life cycle. And now we have to make sure we allocate life cycle responsibilities. So the new version of the standard is very, very specific about roles and responsibilities. So it means that when you're doing your functional safety management planning, you need to consider who needs to be in what role, what their responsibility is for given activities in the life cycle, and more importantly, are they competent and trained to do that? Then you have to develop procedures and making sure that everyone is trained and competent. So the point being is we need functional safety management to help us manage the risk of systematic faults. And if we have poor functional safety management, then we can expect to have higher systematic issues. So again, what does this mean for me as a manager? Managers need to be able to demonstrate competence themselves in terms of having the requisite knowledge of the legal and regulatory functional safety requirements. They need to have some knowledge of what OSHA requires, if it's an OSHA PSM or COMA in the UK, and they need to have a knowledge of the standard itself to understand why things are done and when they are done. They obviously need to have adequate management and leadership skills appropriate to their role in the SIS. So if it's a plant manager, the plant manager has overall responsibility for the site, the plant, the personnel, and that also includes any safety systems. So the plant manager needs to have an overall feel and understanding for why things need to be done from a functional safety perspective, and also to understand potential consequences that could occur. Managers also need to read incident reports. So in the case of the Texas City, for example, there were lots of incident reports and internal audits that were done highlighting all these problems, but management either didn't consider them to be significant, didn't want to consider them, or just didn't care. And this is where the culture plays a really strong role, because if managers see incident reports or audits that are highlighting problems, whether it's problems with training, whether it's problems with faulty equipment, whether it's problems with false trips, all of that needs to be considered. Another way of approaching it is to consider the use of leading and lagging indicators to monitor the SIS performance and risk. Now, there is a webinar that I did on leading and lagging indicators, and there's a paper to go with it. So if you want to know more about leading and lagging, go visit the website again and have a look. But basically, the idea is that leading events or leading indicators help us predict the possibility of a future event. So in other words, looking at how often we train our people, how often are we doing our proof testing? Are we doing it on time? Are we doing timely repairs if we find problems? Are we conducting mechanical integrity? In other words, replacing equipment as it comes to the end of useful life. If we're not doing any of that, or if we're doing it poorly, then all we're doing is saving up potential problems for the future. So that's the use of leading indicators. Lagging indicators, on the other hand, are looking at events that have already occurred, such as near misses or real trips or incidents, releases, fires, things like that. Because what that will help us to do is to look at how we're dealing with these things in terms of, are our policies and procedures correct? Are our people properly competent to do this? Understanding the ramifications. They also need to make sure that they understand what happens if they decide to cut cost. So in other words, if they say, well, we don't really need to do proof testing this often. We can stretch it out. Yes, you can to a certain point, but you have to understand what that will do in terms of the integrity of your SIFs over time. So they can't just willy-nilly make these decisions arbitrarily to cut cost because somebody in corporate says we need to cut 15% off our budget. They need to understand what are the ramifications. And as I said, if there are incidents that are traced back to the fact that a manager made some cost cut, then they could be held liable and culpable and could end up going to jail. So managers themselves need to be trained in understanding what process and functional safety is all about. In this case, ignorance is no excuse. So managing systematic failures. Many of you have been on the FSC 100 know that I talk about the 3 Ps when it comes to this. This is people, procedures, and paperwork. This means that we have to make sure that our people are properly trained and that they are competent to do the work that we are requiring them to do for the SIS and the safety life cycle. Secondly, procedures. Are the procedures in place and being followed? So again, we have to make sure procedures are correct and that they're being followed. And of course, the paperwork is the 3rd P to prove that we are following. So in other words, we're documenting testing, we're documenting repairs, we're making sure we follow procedures. And we would tend to apply the same redundancy to these as we would for equipment. So we might have, for example, if we require some critical safety equipment to be calibrated, we might say that the procedure has a 4 eyes requirement. In other words, the person responsible for doing the calibration carries out the calibration, and then maybe a supervisor or senior person comes and checks it, just to make sure that the calibration has been done correctly. In that way, if we do this right, we won't create problems, or rarely create problems, and we can easily identify when we do, and then we can correct them. So what enables us to do that? Well, we have 2 tools at our disposal. We have functional safety assessments and we have functional safety audits. The purpose of the functional safety assessment is to provide us with an independent, and there's the key word, and that's why it's caps and bold, it's independent and diverse cross-check of safety lifecycle work. So in other words, if people have been doing some of the design work, then they shouldn't be involved in doing the functional safety assessment. They shouldn't be responsible for it. They might be asked to get involved, but they should not be responsible for doing it. And the purpose is to look and see whether the SIS, Safety Instrumented System, meets the safety requirements specification and actually achieves functional safety. So this is very important. We have to make sure that the as designed and installed SIS with its SIFs will actually achieve what we want in terms of risk reduction and providing the necessary functional safety. So membership of the assessment team should include at least 1 senior competent person who's not involved in the project design, for example, for stages 1, 2, and 3, or not involved in operation and maintenance for stages 4 and 5. And we're going to talk about that. When should an FSA be carried out? Well, this is an interesting one because some people get very confused with what's written in 2016 edition. They think, okay, we just need to do FSA 3. The way that the standard is worded would tend to suggest that until you read 5.2.6.1.4, where it says, an FSA team shall review the work carried out on all phases of the safety life cycle prior to the stage covered by the assessment that have not been already covered by previous FSAs. So what does that mean? Well, it means if you're going to be doing your first FSA as FSA 3, which is one of the mandatory FSAs you need to do, then you have to make sure as part of FSA 3 you cover FSA 1 and 2 if they were not done before. So this is very important, because if you see FSA 3, stage 3 is after commissioning and validation prior to startup. So if that's the place where you do the first functional safety assessment, you are running significant risk, because if there are problems, you cannot start up. And therefore, fixing the problems becomes far more expensive and, of course, can result in costly delays. So, as I tell students in the classes all the time, these 5 functional safety assessments are there for a reason. You need to do them because it provides you with a safety net. So stage 1 would be done after the hazard and risk assessment and the initial safety requirement specification. And what you'd be looking for there is to make sure that the hazard and risk assessment was done correctly, the LOPA was done correctly, that we have the right number of SIFs, and that the SRS reflects correctly the requirements. Stage 2 is after you've done the design. So you could do this during FAT, for example, where you've got the hardware and the application software coming together for the first time. So that would be a good place to do FSA 2, to make sure again that what we've got in terms of the physical logic solver and the application software and the I/O is correct. And then stage 3, of course, is after we've done commissioning and validation. So that is very important. The standard now says that you need to, after you've been running for a while, and it says periodically you have to do performance assessment. That's the stage 4. So stage 4 is also mandatory. And then after modification, we need to do a stage 5. The purpose is to make sure that any modifications are properly assessed from the safety point of view. And if it has an impact or ramification on the SRS, then we have to make sure that the SRS properly reflects any changes. It also says that if you have application logic changes, then all the SIFs that are affected by that application change should also be reassessed. So the functional safety assessments are there to help us manage systematic issues. They should not be missed. Certainly you have to do an FSA 3, but if you do FSA 3, you've still got to cover what FSA 1 and 2 is supposed to do. So you might as well do FSA 1 and 2. Functional safety audits, on the other hand, are different from a functional safety assessment, and the purpose of the audit is to ensure that the functional safety management systems in place are up to date and are being followed correctly. This is where we dot all the I's and cross all the T's. And as with any audit, any deviations or discrepancies need to be highlighted and corrected within a reasonable time frame. So here again, as part of our functional safety management, we would specify how much time we would allow for any deviations or discrepancies to be corrected. So those are the 2 key tools. And so when we're looking at functional safety management, and it's highlighted here for a reason, it really does depend upon the company safety culture. Because if the company, in this case, the senior management and the mid-level management all the way down are not committed to functional safety or to process safety, then it's going to be very difficult for the guys at the coalface to be able to implement functional safety correctly. Also, it's about planning. There should be a safety plan. You need to create a functional safety management plan. How are we going to ensure functional safety, and how are we going to manage it throughout the life cycle? This is where roles and responsibilities come in, and we also need to have records of personnel competency, any training that's done. These people who are assigned particular roles, are they capable of doing that? And then, of course, documentation and documentation control is very important, making sure that we carry out our audits. And here again, the standard doesn't define how often you need to do your audits. That would be something you would need to define yourself. functional safety verification and assessment. How are we going to ensure that once we've got an SIS designed, how do we test it? How do we make sure it meets requirements? And then once it's installed, ongoing maintenance. How are we going to ensure that we do that? And then you document your processes and procedures. So the objectives here, again, for some functional safety management is not necessarily to reinvent the wheel. And I've had conversations with several companies of late where I've explained that we can look at what quality management system is in place. And most companies, most end users will have some form of ISO 9000 quality system in place. And they may have quite a few elements already of a functional safety management program or management procedures, but they're just not calling it that. So you can create a document called a functional safety management plan. You can refer to existing procedures that you have. If there are gaps, and usually we can come in and do a fairly quick gap assessment, it's easy to plug those gaps, and then you have your functional safety management plan in place. So the management activities and the technical activities would be defined as what you need to do to maintain functional safety. This will cover things like performing functional safety assessments and audits, and making sure people are properly trained and making sure procedures are in place. So how do we do this? We could appoint one or more person to lead the functional safety activity. They will require management support, and whether that's the plant manager, whether it's the process safety manager, whoever's responsible, they need to be supporting this, but they also need to have a sponsor from the executive committee or the board. You develop the functional safety related procedures, and then you plan, execute, audit, and improve. Normal management stuff. So it's important to do that, and it's also important as part of your functional safety management to encourage an open and learning environment. And what do I mean by that? Well, if anybody working in the plant, working with the system, if they see something that is dangerous or potentially dangerous, they have the authority to stop the process and flag it or record it without fear of retribution. And that's what you need to encourage. You need to encourage your personnel to keep their eyes open, make sure if they see something that's not right, that they have the authority to be able to stop things before it leads to any incident. So roles and responsibilities, as I said, this is something that's been strongly emphasized in the 2016 edition. So again, this means it has to be clearly delineated and communicated. If somebody's responsible, they need to know they're responsible, and they need to know what is expected of them. So there needs to be a definition of the role. And that has to occur for each phase of the life cycle and the activities associated with it. So this is one of the specifically noted primary objectives of functional safety management, is roles and responsibilities. Documentation objectives. So what needs to be documented? So here again, it's any information that we require to effectively perform particular phases of the safety life cycle, the management of functional safety, any verification and validation of functional safety assessments. And here again, we talk about the 4 R's. This is the right data, the right format, the right time, and the right place. Because very often problems occur during transition. So for example, you might have one group who's responsible for doing the analysis phase and another one that's responsible for design. And therefore the information that's transferred across, which should be the SRS, should be in a format that they can handle and should be complete up to that point. So it has all the right information. If not, you could end up with potential systematic issues creeping in. Okay, so let's just summarize. So 1511 defines that functional safety management system has to be put in place to manage the safety lifecycle activities. That is a requirement. You have to have an FSM. And managers need to know this, and managers need to be responsible for ensuring that this is followed. Whether they do it themselves or whether they, again, assign somebody who's responsible and understands that role and is competent to handle that, that's fine. Having the right safety culture is imperative. Can't stress that enough. Management, again, has to understand and support functional safety management or it won't work. Simple as that. And then our 3 Ps have to be covered by any functional safety management system. The purpose of the 3 Ps is to help protect against systematic errors. We don't want systematic errors creeping in. And then the functional safety assessment and functional safety audits are required to ensure that our procedures and our processes are being followed, but also it's good practice to make sure that we're continually improving. So making sure that if we find issues or problems, or if we can